Welcome to Operations and Supply Chain University. I'm Jerry Wright. This is lesson number 15, Process Capability. So the impact of variation on the customer, a lot of times we don't think about this. So how is our process going? Let's say that we're acquiring something and it needs to have a resistance of 10 ohms as an example. So we can see this measurements here. We've got some that are at 9.9 ohms, some that are 10.5 ohms. We've got a fair amount of variation. Now, do we even know if our process is capable of meeting the needed requirements? What are the customer specs? We'd have to look at that. The customer says, okay, I can take ohm reading of 9.96 on the lower specification, and I can go to 10.44 on the upper specification. Anything below that lower spec or above that upper spec is defective, and I can't use it. So how good is our process? If we can't prevent the defects, then we must measure our process and try to reduce the variation. That's really what process capability is all about. So process capability is the inherent ability of a process to meet the expectations of the customer without any additional efforts. So we have to have our process be capable. It gives us an insight as to whether the process has a centering issue, meaning is it this way, that way, or does it need to be tightened relative to the specification limits? Is there a variation issue, or is it a combination of both centering and variation, or do we just have bad specification limits? We really don't understand them. It gives us a baseline metric for improvement. Another way to look at it is we have a statistical problem. What is the probability of our process producing a defect? So we define this practical problem. We create this statistical problem, which we'll walk through in this lesson. We correct the statistical problem, and then we apply that correction to the practical problem. That's really the method we would follow. So let's look at this in a little more common terms. So here we have a distribution of data. I have my lower spec limit on the left. I have my upper spec limit on the right. And again, in order to reduce variation, I need to go from the green distribution curve into the orange distribution curve. And I want to go even further into the tan distribution curve in the center. I want to make sure everything is inside my specification limits. We need to do that for everything that's critical to quality, or CTQ, critical to quality. Then we work on reducing variation. So let's look at this from a standpoint of a couple different measures. Here's potential capability, that's CP, versus sigma level versus ppm, or defects per million, parts per million. If you see down there on the bottom between the lower and upper spec limits there, my bottom level is a CP of 0.67. My sigma level is 2.0, and my defective parts per million made is 308,540. Clearly, this is not going to work. I'm generating too much in defect. If I move up to a sigma level of 3, I have a CP of 1. Now I only have 66,800 defects out of a million. Where I need to be, and where this is an expectation, is I want to be at a CP of 1.33 or a 4 sigma level or higher. That means my defects are only 6,210 out of a million. So that's pretty high. Now, if you keep going up, you can see 1.67 CP and a sigma level of 5 means I only have 233 defects per million. That's really, really low. And at the 6 sigma level, I have a CP of 2, a sigma level of 6, and of course, defects per million only 3.4. So I want to keep working on reducing that variation. Where are you at now? You're probably somewhere between 2 and 3 sigma, but you need to get to 4 sigma or better. That's the goal. Now, measures of capability. So a couple things on the statistics side to make sure you understand, and they're pretty straightforward. PPK is population potential capability. That means it's the entire data set. It's everything. It's long-term. CPK is more process capability relative to the spec limits and a more short-term thing. So mathematically, CPK and PPK are the same, as well as CP and PP. Those are potential capability. They're the same. The only difference is the source of the data. Short-term is going to be CP and CPK. Long-term is PP and PPK, respectively. So CP and PP, what is possible if your process is perfectly centered? It's the best your process can be, and it's good process potential. So this is hope. The reality is CPK and PPK. It's how the process is actually running and how is it doing relative to the specification limits. So mathematically, this is what it looks like. Potential capability, short-term or long-term, is the lower spec limit minus the upper spec limit, or the difference in the two, divided by 6 times the sample standard deviation. Now, CPK is the sample mean and the closest spec divided by 3 times the standard sample deviation. So think of K as a penalty for being off center. Let's look at this graphically. It'll make more sense that way. So potential capability is the ability of a process to have less variation around a specific average or mean, meaning it's a tight grouping. It's getting closer together. You can see the more clustered or the narrower the distribution of the measurements, the higher the CP. So way at the top or less than 1 at the bottom or at 2. Remember, we want to get above 1.33. Okay, potential capability is that grouping or clustering. We really get an idea of how good is our centering, how good is our variation, and then our spec limits, are they good or not? And you can see that's kind of the intention. Now, one of the things we often want to do is we want to shift the average and then reduce variation. Maybe I'm much closer to the upper spec limit, as you can see here, and I need to kind of move it over. I need to tighten it up and move it closer to the target mean or the target average. So this is a common thing you'll see. So here's an example that needs narrowing. So this happens to be out of Minitab, which is a statistical calculation program that you can use for Lean Six Sigma. The problem with this group, my potential capability is 0.66. So I'm in the, what is that, the 2 sigma level. It's too low. I have too many defects falling below 598 and above 602. This is not going to work. Now, process capability is more of centering. I got to get on target. So you can see as you look to the data set off to the right there, I've got potential capability and real capability. At the bottom, I'm less than -1. Even though my grouping is good, my CP is very high, my problem is that I'm not in the center. I need to be in the center. And that's really what that means. We need to get centered up. Again, we want our CPK to be above 1.33. I want to be at a 4 sigma level or higher. So here's an example of one of those that needs to get shifted. I need to get centered. I'm way too close to that lower spec limit. I need to get it tightened up, but I also need to shift it. So I'm hitting that 600 rather than I'm currently averaging around 599 or so. Again, the CPK on this just happens to be 0.66. Not good enough. I'm at 2 sigma. Unacceptable. I need to be at 4 sigma or higher. So in terms of understanding process capability, I like to use the Dartboard distribution reference. You can see here's a high CP, but a low CPK. I'm tightly clustered, but I'm not centered. Okay. CP is that clustering. The higher the CP, the more clustered the data points are. Now here I don't have either. I have poor CP and poor CPK. The points are poorly clustered, and then they're also poorly centered. I need to get centered. Notice the difference in the distributions of the data points. I have a much greater distribution, a lower sigma level than that. Now here's what I want. I want that tight clustering, but I want to be hitting the target. So I want what I had towards the very first target example, but I want everything centered and clustered. That's really what we're aiming for in process capability. So process capability studies, they're intended to be regular periodic estimations of an ability for a process to meet its requirements or its CTQs. It can be conducted on both discrete and continuous data. They're only meaningful when conducted on stable processes, meaning processes that are in control. They're within the upper and lower control limits. And remember, control limits are different than specification limits. They're commonly reported as sigma level, which is optimal on a short-term performance. They require a thorough understanding of the following: customer business set specification limits, nature of the data being short-term or long-term. We understand the mean, standard deviation, and other statistical measures of the process, and we can assess the normality of the data, and that's for continuous data only. And it's also a good procedure for determining my sigma level. How am I doing? So I've got an experiment that you can do. I'll walk you through it. It's very easy. You can do this with a team. You can also do it by yourself if that's the case, but ideally doing it in a team is best. So the items you need is you need one large spoon or scoop, like a catering scoop, one paper lunch bag, one paper plate, and about 100 or more M&M plain candies, not peanut or the other flavors, but the plain ones because they're more consistent in shape. And then normally there are 3 to 4 people per team. So the roles in the team are one team member is the stabilizer. They hold the bag steady, make sure it doesn't move. The other team member scoops, and the goal is to scoop 15 M&Ms and then dump them on the paper plate for counting. One team member records the counts, and then you can eventually put it into a PC, and I'll show you a sheet that you can use. And then one team member returns the M&Ms back into the bag because you need to keep the bag full with M&Ms. If you find any half M&Ms, you can toss them. Now the rules are this, is you're trying to just determine a means of scooping 15 M&Ms. You can have 14 or 16, but below 14 or above 16 is out of spec and out of control. So the goal is to take about 5 minutes and try to get 20 accurate scoops of 14 to 16 M&Ms between the bag and the plate. The candy should be returned to the bag after counting prior to the next scoop. And then teams may modify the scoops as they like with available materials to improve their accuracy between the different rounds. And there's several rounds to this. Now keep in mind, this is best to be done with a team, but 2 people can do it. A single person can do it. It's not required to be done by a team. Okay, here's kind of the background. This is your M&M experiment template. This is in your Ops University Lean Six Sigma Greenbelt Toolkit, so you can see the things you'd need. And the goal is in the first couple rounds, is just practice scooping. See who can scoop well, or if it's just you or one person, figure out who's got the best average. Then once you think you've got a good scooping process and you know who's going to do it, scoop 20 complete scoops and measure the information. You can enter it here. Okay. Then if you need to make some modifications, maybe you need to put some tape on the scoop or do some other things and then scoop one more time. And we're going to see if you can improve your process capability. Now, the next tab in your Lean Six Sigma Greenbelt Toolkit is the CPK analysis tab. You can see what it looks like here on the left. All you have to do on this particular one is put in your data, your 15, 16, 14, whatever it is. If you have 13s or you have 20s, put them in there and then calculate your CPK. If it's less than 1, like it is in this example, it was 0.726, then you have significant variation. Repeat it one more time, and what was your new CPK? Now, this particular analysis tab has more than 20 lines. We've just kept it to 20, but you can unhide those lines and go up to more. You can even add more lines if you want to go higher. I think it goes to like 60 or 100 data points. So again, the goal is to figure out how you can calculate your CPK and how you can improve it. Again, all you have to do is enter the upper and lower spec limits in the formula and take it from there. So again, this is a great way to help you understand process capability and what it means. I'll give you a bit of background on this. Where this came from was a coating of oil and gas pipelines. They put a Teflon or another type of coating on these pipes, and the goal was to get 14 thousandths minimum, 16 thousandths maximum. And at 14 thousandths, if you had less than that, it would not effectively protect the pipe when it was buried in the ground. If it was more than 16, you're essentially giving away a very expensive coating. So the goal was for the operators to understand that they had to keep between 14 and 16 thousandths in coating these very large pipes. And we used the M&M experiment as a way of making that come to life. And it was very helpful, and it gave a good understanding of CPK and saying, hey, this is not complicated. And by the way, the CPK sheet is just a calculation in Excel. There's nothing complicated to it. You'll have that from your toolkit, and you'll be able to do CPK on any data attribute you'd like to measure, see if your process is capable. So again, process capability, we want to, 1, select the output for improvement. In this case, it was, the 15 to 14, 15, 16 M&Ms. We verify our customer requirements. So in this case, it was 14 minimum, 16 maximum. We validate that we can hit those spec limits. And again, that's why we did the CPK experiment. Collect the data, measure it. Is it short-term or long-term? And for ours, it's all short-term. We don't have long-term data. Then make sure the data is normal. If you plotted it, is it a normal distribution? Most of them are, but that's an example of something you check on. And then finally, you calculate what's your CPK, what's your yield, what's your ppm. You can determine all that once you have the data. And this is a great way to establish process capability, is using these simple tools. So one last thing to do is make sure you verify specifications. What is the source of the specs? Did we get them directly from the customer, the VOC, voice of the customer? That's ideal. Do we have certain business requirements we're trying to hit internally? Is there a target or a benchmark? Or there are design limitations that we have from the blueprint or a system or something like that? You need to make sure you understand those. Are they current? Okay. Are they likely to change? Yes or no? Are they understood and agreed upon? We want to make sure that the specs that you have, the specs your suppliers have, and the specs and the specifications your customers want are all the same and they're measured the same way. Otherwise, you can run into problems. And then we want to make sure that our workforce understands them so we can get a good process capability for whatever we're measuring. That's it for process capability. Here's a recommended reading if you want to get more into the practical application of process capability studies. Douglas Relier has a book that you can pick up which involves from product control to process control. So he covers both products and processes, and it'd be a good read and a backup resource. Thank you for your time.